Hello students, today is our lesson on section 5.3. This is going to be day 1 for part 1. Tomorrow we'll have part 2. Section 5.3 is solving exponential and log equations. So solving equations with exponentials, solving equations with logarithmics, and we'll just do a couple examples and that'll be today's lesson. Your homework will be on quizzes. So let's start with solving an exponential equation first, or a problem involving x and the exponent, like e to the x has to be equal to 748. So what is x? So we have two methods, using logs and using a graphing method. Let's do the log method first. So if we take the log of both sides, we can solve this problem. Or if we turn it into just log form, you can think of it either way. Since we have an e here, we would want to use natural log. So since we have an e, we're going to use natural log or ln. So we can take the ln of both sides. So the ln of e to the x has to be equal to the ln of 748. Okay, and now I can use some log properties. I know that if I have a log with a power, I can bring that power down. So I can rewrite this as x times the ln of e is equal to the ln of 748. Okay. And the ln of e is just 1. If you put that into your calculator, ln e, it's just going to be 1. So this is the same thing as saying x is equal to the ln of 748. And this makes sense because if we just change this equation to log form, we would have said log base e, which is what ln is, log base e to the x power is equal to 748. So taking the log of both sides, or the ln of both sides, gets us to what we would have had if we just went from exponential form to log form. And now we can just solve. X equals ln of 748. That's just a number. We can just plug this into our calculator. ln of 748. So go to the calculator here. Ln of 748, and we get 6.617. We're just going to call it 6.62. We'll round it 6.62. So x is about 6.62. The other method we could have used is a graphing method, where we're going to say y1 is the left side of the equation, so e to the x, and y2 is the right side of the equation, so 748, and we just see where they intersect on the graph. And I've already got it pasted here, but I'll show you on my graph. But we get the same answer, 6.617, about 6.62. So if I pull up my calculator, I go to my y equals, e to the x is my y1, 748 is my y2. Let's just start with a standard window. We don't see where the intersection is here, where our y2 hits our y1. That's because our y2 is going to be around 748. So we need to change our window so that our y max gets to at least 748. I'm just going to say 800. And there you can see the intersection right there. So second trace, intersect, enter, 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 and we get our answer, 6.617. All right, let's have you try the next one on your own. So 4 to the 2x equals 4,096. What'd you get for an answer? Try it on your own. Okay, so if you change this to log form, so we got log, what's our base? Our base is 4. What power is 4 taken to? 2x. What does that got to be equal to? 4096. Log base 4, 4096 is just a number. We can type that into our calculator, and we get that number is 6. So that means 6 has to be equal to 2x. Divide both sides by 2. 6 divided by 2 is 3, so x has got to be 3. So we changed from exponential form to log form. Or you could have taken the log of both sides. So log of 4 to the 2x equals log of 4096. And then brought the 2x down. So then we would have had 2x times log 4 equals log 4096. And then divided both sides by log 4 and gotten the same answer, because this is the same as change of base formula. So if we would have put that into our calculator, we would get the same thing as what we got here. We would have had 2x is equal to 6. All right, last thing we got to talk about, last example, is how do you solve a logarithmic equation? Well, you can use some log properties. You can then change the exponential form and solve using algebra, or maybe use a graphing method. So kind of some 3 things to keep in mind. So when I see this problem here, first thing I think about is using a log property. That log property would be that when we add 2 logs, it's the same as multiplying what's inside. So this is the log of 3x times 5x equals the log of 375. And 3x times 5x is going to be 15x squared. 15x squared. And now what can I do? If I have the log of something is equal to the log of something, well, then those somethings have to be equal to each other. If the log of A is equal to the log of B, then A and B have to be equal to each other. Or in this case, 15x squared has to be equal to 375. So I can just remove the logs from both sides. I've got a log of something equal to the log of something. Just remove the logs and just set the something equal to something. So x squared is equal to, 15x squared is equal to 375. So if I divide both sides by 15, I got x squared is equal to 375 divided by 15. If I go to my calculator, 375 divided by 15, 375 divided by 15, I get 25. So x squared is equal to 25. So x is equal to the square root of 25. So x could be plus or minus 5. Now the tricky thing here is a lot of times with logarithms, a negative answer doesn't work. We can't have a negative answer. We can't have a log of a negative number. So a lot of times we'll have to double check, plug back in to see, especially if that negative answer works. One way to do that is to check the graph. So if we use the graphing method, we would make our y1 be equal to the left side and make our y2 be equal to the right side. And if we plug that in, we can see from the graph that there is no solution at x equals -5. No x equals -5 solution. It would have been, like right over here. We only have this curve on the positive side. So our answer is only x equals 5. X equals -5 does not work. Let's have you try one on your own. Okay. Here's the problem. We got 2 plus 3 ln 4x equals ln e to the 6 plus ln x. See if you can solve this on your own. All right, so this was quite the challenge problem. So if you didn't get it solved algebraically, that's okay. I'll show you how to do that. Hopefully, at least try to do it graphically. We'll see if you got the same answer as what we get when we use algebra. So first thing I would do is try to move all the numbers to one side and all the terms with x to one side. So I like to keep the x's on the left and the numbers on the right. So 2 is a number, so I'm going to subtract 2 from both sides. And we got the 3 ln 4x here, so that has an x in it, so we're going to keep it on the left side. Ln e to the 6th, this is just a number. I know it looks scary, but this is just a number, so we're going to keep it on the right side. Ln of x, that has an x in it, so we're going to subtract it away. We're going to move it to the left side, so we'll subtract that from both sides. Once we do that, okay, we're going to eliminate the 2's here. 2 minus 2, 2's are gone. We have 3 ln of 4x minus ln of x. So 3 ln 4x minus ln of x. We have ln e to the 6 minus 2, and the ln of x's are canceled. So we have ln e to the 6 minus 2. So everything on the left side has an x in it. Everything on the right side is a number. We could literally just plug that into our calculator. So next step, I'm gonna move that 3 up into the exponent. So I've got ln 4x to the third minus ln of x. Over here, you could just plug all this into your calculator, or just using some properties here, good practice. I move the 6 down. So I've got 6 times ln of e minus 2. Next step, 4x cubed is the same as 4 cubed times x cubed. So 4 cubed is 64. We've got the ln of 64x cubed minus the ln of x. 6 times ln of e. ln of e is just 1. So this is 6 times 1 minus 2, or just 6 minus 2. Next step, we're going to combine those two logs. So I've got subtraction here. So subtraction of logs is the same as division. So I've got the ln of 64x cubed divided by x, all in one natural log. 6 minus 4 is 6 minus 2 is 4. Next step, I'm going to rewrite this into exponential form. So ln is base e, okay? And so that's why I wrote the e here. And I simplified the x's. If I got x to the third on top and x on bottom, one of these is going to cancel, so we're left with 64x squared. So what does that look like in exponential form? Well, it's e to the, it's e, base e, to the 4th power. So e to the 4th power is equal to 64x squared. So if e to the 4th power is equal to 64x squared, I divide the 64 on both sides. Divide the 64. So I got e to the 4th divided by 64 equals x squared. Well, I can just go to my calculator. So e to the 4th divided by 64. I get 0.853. Okay, 0.853. 0.853 equals x squared. So then I just square root everything. And what is the square root of 0.853? Second square root 0.853. And we get about 0.923. 0.357, blah, 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 blah. And again, this could be positive or negative, so we should check it with our graph. All right, we just move this a little bit. So x is equal to all that. Now let's graph it. Okay, that seems like a pretty nasty one to graph, but let's check it. Okay, so y1 is going to be the left side, y2 is going to be the right side. Let me plug that in. All right, so there's y1 and y2. We go to the graph. Let's do a zoom 6. We see the two curves. Second, trace, intersect. You might have to arrow over. First curve, enter. Second curve, enter. Guess, enter. Intersection at 0.9236. And no negative answer, just one answer, just one positive curve there. So we know the answer is that positive 0.9235, blah, 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 blah. Same thing we get here on the graph. Now the answers are slightly different, but that's because I had to round, I had to round the 0.853. So when I found 0.853 right there, that was actually rounded. It was 0.8530 something, something, something. So when you see the intersection at 0.9236, that's why it's a little bit different than 0.92357. All right, that's today's notes. Try the homework on the quizzes.